myself Pooja Waghdhare. I hold my master degree from Instrumentation Science Department, Pune University. Total, I have more than 6 years experience in a teaching field. Now I am working with a different institute as a same. As we know that the world is suffering from corona issue, and as a teacher I feel that students may not suffer from this. That's why we got this idea of online teaching, and I know that with my education, knowledge and ability I can serve a better education for my students. Thank you. Myself Pooja Waghdhare, and I'm working with the Swami Academy. So today I'm going to give you a lecture on 12th class first unit topic, that is electrostatics. So before starting with the electrostatic, let's understand shortly about the physics. Do you know that what is physics? In simple word we can say that physics is the science which deals with the nature and the natural phenomena. The everything occurring around us, twinkling of star, raining, and everything depends upon the science of the physics. So we can say that physics is the father of the science. So let's understand about this physics. The first chapter or the first unit of this 12th class physics is electrostatics. See, remember, whenever you want to understand a particular topic in physics, firstly understand the meaning of that topic. If you get that, you'll able to connect with that topic. Okay? So electrostatic is a branch of physics which deal with the electromagnet. In electromagnet, there are again the two different branches. One is electrostatic and the another one is when we can say that the electric motion. Okay, so in electrostatic, which means that electro means charge and the static means at rest. When the charge is at rest, we can say that the various phenomena occurs over there. And the second one is when the charge are in motion. When charge are in motion, which means that when charge are moving, when charges are moving, it produces a current. When the current is produced, we know that if some current is flowing through a conductor, it shows the magnetism. So there are different branches which deal with when the charges are in motion. This unit we are going to see about the electrostatic. Okay. In electrostatic, the subtopics are charges, that is electrostatic charges. The second important is electric field. Third one is electrostatic potential, and the fourth one is capacitance. So now I am going to give you the brief description of each subtopics. Now let's start with the charges. In charges, we are going to see the definition, properties and laws regarding this charge. So let's understand first that what are charges. You heard about the charges. As we know that the matter is made up of atoms or molecules, and the subatomic particles are there with the atoms. They are electrons, protons and neutrons. Electrons are negatively charged particles, protons are positively charged particles, and neutrons are neutral. We are talking about these charges. What are they? In simple word, you can say that charges are intrinsic properties of matter. What does mean by intrinsic property? The something which cannot be divided into further. So this is the least thing about the matter. So charges are like that only. So this is a definition of the charges. Next thing is properties. For the properties, we'll take some example. Let's say that I'm having a silk rod with me. I used to rub that silk with the silk cloth. Another rod, I'll take the glass rod, and another it will rub with the silk cloth. Now if I subtend these two rods, the two different glass rods, what we will observe? We'll observe that both the glass rod will get repelled to each other. Why this is happening? As we know that every particles or every object are electrically neutral, which means that there are equal distribution of positive and negative charge. Then why they get repelled? This is because the electrostatic property. In this property, you can observe that when the glass rod rubbed with the silk fur, two different equal but different charges develop on that. On a glass rod, positive charges develop, and on silk fur, negative charges developed. So when the another glass rod having a positive charge come in contact with the glass, it will get repelled. So this is a first important property of charge. Two equal but the opposite charges attract to each other, and two equal but the like charges. This is like. Plus one is plus and the another one is plus. So they will repel to each other. Okay, got it? Charges are of two types. One is positive, another one is negative. So the thing is what? Two equal but the like charges repel with each other, and two equal but the unlike charges attract each other. Okay, this is a property of charge. Next important property is quantization of charge. Understand this thing. Quantization of charge, you can write it as Q, which is equal to integral multiple of charge on electron. Understand this? Q is integral multiple, N is your integral multiple, and E is a charge on one electron. What is a charge on one electron? It can be, no, it is fixed. It is what? 1.6 into 10 to the power minus 19 Coulomb. If this is charge on one electron and in your system there are n number of charges, the total charge on a system will be Q. 1 mark question, that is 1 mark numerical, will come with this particularly formula. Okay, this is quantization of charge. Next is unit of charge. We measure something in some units. Let's say that if you want to measure a length, so we will measure it in SI unit of meter. Similarly, if we want to measure the charge, it will measure with the SI unit coulombs. Okay, so SI unit of charge is Coulomb. The next is additive property of charge. As we know that charges are two types. One is positive, another one is negative. So this property, additive property of charges, is in a system there will be a number of charges. We have to add that with their signs. Let's say that in a system we are having a charge like plus 3 Coulomb, minus 2 Coulomb, plus Coulomb, plus 1 Coulomb. The three charges are there. So what will be the total charge in a system? We have to add it with the sign like plus 3 Coulomb, minus 2 Coulomb, and plus 1 Coulomb. So 3 minus 2 plus 3 and minus 2 will be the 1. 1 plus 1 is equal to 2 Coulomb. So this is the total charge in a system. This is simple property. So these are the properties of charges. Next important topic is Coulomb's law. This is under the charges only, and this is a very basic and important law in electrostatic, or we can say in physics. So if we are able to understand this law, we will be able to solve the other things regarding electrostatic. So Coulomb's law states that the force of attraction or repulsion between any two charges is directly proportional to product of their mass. Let's say that a mass on one charge is directly proportional to product of the charge on one and the charge on second, and it is inversely proportional to the square of distance between them. So let's say that in our system there are two charges. One is having a magnitude of q1, another is having a magnitude of q2, and the distance between these two, which means that distance between the center of one charge and the center of another charge, both charge are in static in nature. Okay, so that will be the distance will be the r, so it is inversely proportional to r square. Combinedly, we can say that this is q1 q2 by r square. This is proportionality. If you want to convert it into equal, if something is proportional, we have to add some constant in that. So this will become F is equal to K q1 q2 by r square. This is your Coulomb's law. K is a constant of proportionality. The value of K is 1 upon 4 pi epsilon naught. Epsilon naught is permittivity. Permittivity, it means allow something. If the charges are moving in particularly space or any other media, the media has a right to decide how much charge it can allow. So that is permittivity. So the K is nothing but 1 upon 4 pi epsilon naught. This is a constant. This is about the Coulomb's law. Further in details, we are going to see this Coulomb's law in a vector form. Vector is a physical quantity in which magnitude as well as direction is required. So you can modify this. F is the force, which is a vector form, and here you can write it as K q1 q2 r square into r cap. R cap is a position vector, which means that you can write it r cap is equal to r divided by r bar, which means scalar of that particularly distance divided by the vector, which gives the direction vector of particularly quantity. Okay, this is about Coulomb's law. This is something about this is about the subtopic of charges. The next is electric field. What will be the electric field? As we know that we always heard, we all love cricket. So in that we always heard about we are playing a cricket in particularly field. The field is something which is shows the particularly action. Okay. So similarly here the electric field will be the field around that electric charge. Okay. So electric field is what? The field, the space around the charge where it shows the property or this force of attraction or repulsion around it. Okay, this is electric field. So for this electric field, we can say that electric field is denoted by E bar is equal to force divided by charge. So E is equal to F divided by Q naught. Q naught will be the test charge for which we are observing. Okay, so that will be the Q naught. E is the electric field. You can say that electric field intensity also, which is equal to F, that is the force of attraction or repulsion, which we have seen already in Coulomb's law, divided by Q naught is the charge. You can find out the SI unit of this electric field. What will be the unit of force is Newton. divided by the unit of charge is Coulomb. So what will be the unit of electric field? It will be Newton per Coulomb. You don't have to remember this. You can find out each and every SI unit if you know the formula. Okay? And this is also come particularly for the numerical. Numericals are the things which gives you the direct marks. So if you know the formulas, you can use this in the numerical. Or you can write it as, we know that F by the Coulomb's law, the formula of F, you can use it. So E can be written as F is what? 1 upon 4 pi epsilon naught Q1 Q2, or you can write a Q naught Q1 divided by Q naught R square. This Q naught will get cancelled. So what will be the formula? 1 upon 4 pi epsilon naught. For Q1 you can write it as a Q divided by R square. So this is also a formula of electric field. I'm giving you the different formulas which are you can use for the numericals. Okay. So E is equal to F divided by Q naught, and it is also 1 upon 4 pi epsilon naught, which is a K constant, into Q divided by R square. Q is the charge which is observing or which can experiences the forces, and R is the distance. Okay. So this is about the electric field. Next is electrostatic potential. Okay. What will be the electrostatic potential? Let's say that I'm having two different points. So if any unit positive charge, you can take a negative charge also, but for the simplicity we always take a positive charge. Okay. So if the unit positive charge is moving from one point to the another point. Okay. If the unit charge is moving from one point to another point, how much work it will done is nothing but electrostatic potential. Got it? I'm repeating. If a unit positive charge is moving from one point, from one potential to another potential, how much work will be done is electrostatic potential. Electrostatic potential is denoted by V. Charge is moving from A to B, let's say that, which is equal to work done over a charge. As simple as that. What will be the SI unit of this electrostatic potential? The SI unit of electrostatic potential will be, the unit of work done is joule, and what is the unit of charge? It is Coulomb. So joule per Coulomb is the unit of electrostatic potential, or you can say that it will be volt. So 1 volt is equal to 1 joule per 1 Coulomb. So if we want to define 1 volt, it will be a moving unit positive charge having a charge of 1 Coulomb. The work is done 1 joule. So it will be 1 volt. And this charges is always flow from higher potential to lower potential. Okay. So this is about the electrostatic potential. Now the last subtopic is capacitance. Capacitance, electric capacitance, is the ability of conductor to store the charge. So capacitance is very helpful whenever in any circuit we require utilization of charge. We use this property of capacitance. Capacitor, don't confuse with the capacitance and capacitor. Capacitor is device which stores the energy. So it is device, and the capacitance is a property. Let's say that the simply you can see, if 2 two metals rod are there. One is having a positive charge and the another is having a negative charge. So as I told you, electrostatic potential is always flow from positive to negative. So this will be the direction of electric field, and the magnitudes having a positive and negative charge are same. So this is about the capacitors. So it looks like this, okay, and we have to connect it to a potential or with a battery to make it flow. So this is about capacitance. So these are the subtopics which we are going to see in electrostatic, and in that further in details we are going to see the various derivations like electric field when the point lie on an axial line. Axial line means on the horizontal line. Equatorial line yani making some angle with that, and so on. Similarly, we are going to see the various derivations for the electrostatic potential with the same. So there are very vast but the interesting portion is there in electrostatic. The almost 40 to 50% of your 12th syllabus is covered under this topic. So this is an interesting one. If you want to learn a detailed study of this, you can start the online coaching with us. Thank you.